Remember that from the last class that we had, we worked with the laws of exponents, which is a combination of everything that we are having here. And like I said, I want you guys to work with more questions so that we'll be able to understand whatever that we are going to be working with. So some of these questions, you definitely need to be very, very careful the way that you are going to simplify them, but having your laws of exponents in mind. So if you have not watched the introduction, make sure that you do so, because this is a continuation from that previous exercise that we had. In this part, I want us to check more questions from the question number 19. If we are given to simplify like what we have, this is a to the exponent of 2 into a to the exponent of x minus a 2. Remember, the question was to simplify this using the laws of exponents or the index laws. We talked about the laws of our exponents listed above there, and they say that whenever the bases are the same and you are multiplying, because this is a product, the bracket is a product. This simply means this is a to the exponent of 2 times a to the exponent of x minus 2. It's a product. That is what they're trying to say. So remember that if the bases are the same, what are we going to do? We are going to add the exponents. So this is a to the exponent of 2 plus you add the exponent of x minus 2. Remember what I said on the introduction, that if you're adding an algebraic expression, it is best that you open a bracket, but for addition does not affect. But whenever you subtract, there is a need for you to do that so that you properly affect everything by the sign that is given there. So this is a to the exponent of 2, distribute by 1 times x, that is going to be x, 1 times negative 2, that will be a negative 2. So collecting like terms, 2 minus 2, this is going to give us what? A 0. So you're left with a to the exponent of a positive x. And a to the exponent of a positive x, there is nothing that we can do. There's nothing that we can do from there. So you're done. So these are the typical questions that you are going to actually have in your exams. All you just need is to work with more questions, more revisions. Make sure that you equip yourself for the exams ahead of time. Number 20, we have got a same situation. That is x to the exponent of 4 to the exponent of 2 times xy to the exponent of 3 to the exponent of 3 times x squared y to the exponent of negative 2. Everything is being affected by x cubed, y cubed to the exponent of 2 times xy. So never be afraid about how many terms are there. Apply your laws. Use your laws properly. Apply the laws properly. So if you are to consider, there is an exponent and exponent. Remember what we said about the issue of the exponent and an exponent. If you're given exponent, you multiply together. If there are terms under the same bracket being raised to a certain exponent, everything in that side, inside of that bracket, will be raised to the same exponent. Everything inside of the bracket. This is the part that we are having here. All right. So there is an exponent, we're going to multiply x to the exponent of 4 times 2, which is 8, all right, times. We move on to this. So this is x to the exponent of a 1 being raised to the exponent of a 3. So it's going to be 1 times a 3. So this will be x to the exponent of a 3. The same thing with this y being raised to the exponent of a 3. So it's going to be 3 times a 3. So 3 times 3, that is going to be to the exponent of a 9. We do the same thing on this part. This is x being raised to the exponent of a negative 2. So that's 2 times minus 2. So if you multiply 2 and minus 2, that will be a minus 4. Y is being raised to the exponent of a 1 and is being raised to the exponent of a negative 2. So that will be 1 times minus 2, which is to the exponent of a negative 2. So this whole part is going to be divided to what we have in the denominator, and having the same thing, x to the exponent of 3 is raised to the exponent of 2. So that's 3 times a 2, which is going to be a 6. So that's x to the exponent of 6 times y to the exponent, the same thing, 3 times 2, that is going to be y to the exponent of 6 times x times y. That is the xy that we are seeing there. So this is the case. We have managed to separate these terms, but considering here that I said before, if you are multiplying the bases that are the same, you are going to add the exponent, and if you're dividing, you subtract the exponents. So this is what you're going to have in place of x, or considering the part of x. All right, where are we multiplying? We are going to add. So let us just consider what we have on the numerator first. So we're just going to consider the numerator only in this case. Yes, you can combine everything, is fine. So in this case, I'm going to consider the part of x in the numerator only. So that is going to be x to the exponent of 8, you're multiplying. So we add plus a 3, we add plus a minus 4 like this. The same thing with the y to the exponent of 9, y to the exponent of minus 2. So we're going to add 9 plus minus 2. Everything is being divided to the denominator. We do the same thing, the part of x together. This is x to the exponent of 6, and this is an x. Whenever the x is given with an invisible power, it means there is a 1. Power is there. So this we are going to add. Whether it's in the denominator, we are multiplying. That is what is important. So we're going to add 6 plus 1. That is it. Then we move on to the part of y. We are going to add again. So this is same as y to the exponent of 1. So we add 6 plus 1, just like the previous case. That is going to be a 7, 6 plus 1. All right. Anyways, we can just simplify this straightforward on our calculator. So this is going to be x. Let us simplify the numerator first. All right. So you're going to simplify the numerator. So if we add these numbers, this is it here, guys, with your calculator. That's 8 plus a 3 plus a minus 4. A minus 4 like this. So this will give us 7. So that's x to the exponent of 7. 9 plus minus 2. So that will be 9 plus minus 2 is same as 9 minus 2, which is a 7. So that's y to the exponent of 7 over. If you add that is going to be 6 plus 1, which is a 7. So that is x to the exponent of 7. 6 plus 1, that is a 7. So as we can see, what we are having in the numerator and what we are having in the denominator is the same. These two are exactly the same. So that will be 1 over 1, which is going to give us a 1. So this is how our question was supposed to be like. That is how our question was supposed to be given as, or a simplification, in the simplification. So like I said, you just need to be very, very careful in the simplification, the way that you're given your questions. You just have to be very, very careful. All right, let us consider another question that we are given. Then if there is any other question that you feel like we can work on, let me know so that we can work those questions. But as far as these laws of exponents are concerned, this is how you need to simplify these typical questions. All right, so that is how you're going to have your questions simplified. And some of these numbers, guys, just use your calculator, they multiplied. Some of these don't need to use your laws of exponents there. All right, 1 over 6, whatever that you're given there, just multiply the numbers. All right, let me just do this number 25 there. Some of these questions, you don't even need to apply the laws. Just multiply 1 over 6 times 3 over 12 times 15 over 20. So this is 1 over 32. So we've got 1 over 32. Okay, and this is like this. So this is going to be like this times everything is going to be raised to the exponent of -2. So it's x to the exponent of -2 over y to the x. But look how weird this question was going to be. So how can we avoid this thing? We can avoid it by interchanging. Whenever you have a negative like this and there's a fraction, x over y like this to the exponent of negative m. Whenever you have this, I want you to note this. You interchange inside the fraction, inside the bracket, you interchange. So this will be y over x. The moment you interchange, this sign changes to be a positive. So meaning to say I can just interchange this, it will be y over x to the exponent of a positive 2, just like that. And take note, what is being raised there, it is not the 1 over 32, no, it is the y over x. So we are going to have y to the exponent of 1 to the exponent of 1. Remember everything? So that's 1 times 2. Remember, an exponent and an exponent. It's going to multiply. So that is now y squared over 1 times 2, which is going to be x squared. So meaning to say, we can even simplify the numerator to the numerator. 1 times y squared, that is y squared over 32 times x squared, which is 32x squared. Just like that. Just like that. So as long the laws are being applied, as long you are using your laws properly, you're going to see that you're not going to have any challenge in the simplification. All right, I'm going to do last question, which is question number 29, but I would like you to do as many questions as you can. Like I said, where there is a challenge, let us communicate. The comment section is there for that, so that we can work with those similar questions, even past exam papers. So on this question, we are given x to the exponent of minus 2. So it's all about that exponent concept. The xy to the exponent of m, everything will be raised to the exponent of m. So meaning to say, this will be raised to the exponent of minus 2, this to the exponent of minus 2. But there are exponents already there. So meaning to say, this will be x to the exponent of minus 2 times minus 2, which is a positive 4. Y to the exponent of 3 times minus 2, which is a minus 6. The same thing, you do it here, x to the x, there is a minus x3 there. X to the exponent of 3 to the exponent of minus 3. So exponent, exponent, there, exponent, exponent. You multiply. So that is the case. So that will be x to the exponent of 3 times minus 3. That's a negative 9. Y to the exponent of minus 3 times minus 3. That's a positive 6. We are back. Whenever you are dividing the bases that are the same, x to the exponent of m over x to the exponent of n, you subtract the exponents. So meaning to say, here we are going to subtract. Here we are also going to subtract the part of x on its own, x to the exponent of m, all right, sorry, x to the exponent of a 4 minus, what are we subtracting? It's already carrying a negative, so that's a minus 9. Y to the exponent of minus 6, minus what? Minus 6. That is the case. So meaning to say, after subtracting this, what are we going to have? That's a minus and a minus. This will be a positive, or just use your calculator, minus, minus. The calculator does not even mind about that, but that is 4 plus 3, which is a 13. Or on your calculator, just like this, 4 minus this one, you subtract. What are you subtracting? A minus 9. So this will be a positive 13. So that's x to the exponent of positive 13, y to the exponent of minus 6, that's minus 12. But if we are to consider this, we are not supposed to have our questions with negative exponents. So we are supposed to use our laws. Remember, I said before that if a number is being raised to a negative exponent, we can remove the negative exponent by writing this as 1 over with a positive exponent. So just to remove a negative, you write this as 1 over what you are given there. So meaning to say, what is raised to an exponent of a negative is the y, not the x. So it was going to be x to the exponent of 13 times 1 over y to the exponent of a 12. So that is it. So you're multiplying this to the numerator to the numerator, x to the exponent of 13 over y to the exponent of a 12. With this, we can answer as many questions as we can. More questions like this from Meson African motifs till we meet again.